Now, one special case for these relations we just developed is what if you have an isentropic process, or when my entropy change is zero? What can I do then? Well, a great thing from it is that if my entropy change is zero, well, I know this guy right here is zero, and that gives me a relationship between my temperatures, my specific volumes, or my temperatures, and my pressures. Now, you have to do some shenanigans here. One, you have to take into account the definition for your specific gas constant, as well as the ratio of specific heats. And what it'll all come over to are these relations right here. And these should look familiar to you if you've been watching my videos from the very beginning, because a long time ago, I believe in chapter 4, I talked about a polytropic process. And I developed these relations for it. But at the time, this was just my exponent gamma right here. And I told you, like, hey, at some point, we're going to turn that into the ratio of specific heats. We'll go from a polytropic process to an isentropic process. These are absolutely fantastic relations. They make your calculations really, really easy if you have an isentropic process. And they're valid under three circumstances. If you have three conditions met. Number one, ideal gas. Don't do it for water. Doesn't work. Number two, has to be isentropic. That's why they're called the isentropic relations. And the last one is very, very important, constant specific heats. You can only use this if the problem says that you have constant specific heats or you're doing approximate analysis. It has to state that in your problem. Otherwise, it's probably going to be asking you to do what's in our next video, which talks about relative pressure and relative volume. But these are great for really simplifying your calculations when you have an isentropic process as part of your cycle, which you'll be seeing a lot in Thermo 2, or as part of your problems in this chapter 7. So that'll be for this time, and next time we'll jump into how you do this with variable specific heats. Have a good one. Bye-bye.